I am Anil Kumar sharing with you three test questions on sine law application. We'll consider ambiguous cases. Here is the first true or false question. It is in a triangle ABC, angle A and side lengths A and B are given. Now the two questions based on this is if angle A is greater than 90 degrees and A is greater than B sine A, two triangles are possible. True or false. B is if angle A is less than 90 degrees and side length A is greater than B sine A, two triangles are possible. Support your answer with an example. So write true or false and support it with an example. Then we have an application question here which says a light in a park can illuminate effectively up to a distance of 100 meters. A point on a bike path is 150 meters from the light. The sight line to the light makes an angle of 23 degrees with the bike path. What length of bike path to the nearest meter is effectively illuminated by the light? So you can actually pause the video, copy this question, think about it, and then answer. I'll provide you all the solutions in this particular video itself. Here is the last question. It's a straight question on application of sine law. You need to solve the triangle ABC where angle A is 40.3 degrees, side length A is 35.2 centimeters, and B is 40.5 centimeters. So when we are given all the dimensions in 10th place, we expect answer also in 10th place, right? So you can actually pause the video, answer these questions, and then look into my suggestions. Okay, so let's see how to solve these questions one by one. So I'll begin with the very first one here, and I hope you have your answers ready. Take it as a real test. True or false? In triangle ABC, angle A and side lengths A and B are given to you. If angle A is greater than 90 degrees and A is greater than B sine A, two triangles are possible. So we have to answer this question. So part A, we are talking about obtuse angle when angle A is greater than 90 degrees. So it's kind of like this. Let me just sketch it like this. So that is the obtuse angle. And if this point is point A, where the angle is an obtuse angle, we'll always consider the other side, which is on the left side, as B, and A is the side opposite to angle A. So this is the side, correct? So as you can see from the diagram very clearly, side length A should actually be greater than B, not B sine A, correct? Not B sine A. To give you an example, what we can do here is, let's take an angle of, let's say 110 degrees. I wrote this, okay? And let's take B as 12 centimeters. Now what is B sine of 110 degrees? B sine B is 12, so this is 12 sine of 110 degrees. Let's figure it out. So it is 12 sine of 112 is equal to 11.12. So this length is equals to 11.12 centimeters. Now clearly 11.12 is less than 12. So if A is 11.12, then our situation is kind of like this, right? We're not, if this point is C, here we have B, supposed to be. So 11.12 will only reach up to this point, and we are unable to form a triangle, correct? So in obtuse triangle, the condition is that A should be greater than B and not that, and therefore this particular statement is false. Now the next one here is regarding the acute angle triangle. So let's answer this now. So let us again sketch a triangle similar to we did last time. So let's say it's kind of like this now, right? Now here we have side B. So here somewhere we'll have A. Now we are saying that if angle A is an acute angle, like shown here, then A greater than B sine A. So let's take a side length B as equal to, let's say, 10 centimeters, right? And A is greater than B sine A. Two triangles are possible. Okay, let's calculate B sine A. Let's take this angle as, let's say, 30 degrees. Now what is 10 times sine 30 degrees? Let's calculate. So it is 10 sine 30 equals to 5, half, right? So 10 sine 30 is 5. And therefore, what we are saying here is that if A is greater than 5 centimeters, then we have two triangles. That is what the statement is saying, correct? Okay. So what we are saying here is this side here, if it is 5 centimeter, B sine 30 is this side. If A is greater than 5 centimeter, then we have two triangles. That's okay. How about if A is greater than 10 centimeters? For example, if A is equals to 11 centimeters, then what happens? Well, if A is 11 centimeters, we could have a triangle kind of like this. Do you see that? And if I go like this all the way, the angle becomes obtuse and not acute. Perfect. And therefore, this statement is also false. So here, whenever we are talking about acute angle, that is, angle A is less than 90 degrees, in that case, we should consider that side A is actually greater than B sine A, but less than B. So this condition, less than B, is also important. Correct? However, it could be equal to B or not. That is to be considered. So if A and B both are equal, if A and B both are equal, that means 10 centimeters is here, then you have the same triangle. Do you see that? If I have, then they become equal. Isosceles triangle. Correct? So it will be a condition like that. So, but not two triangles, only one triangle. So A has to be between B sine A greater than this and less than B. So that becomes the condition. Is that okay? So it is also false. So this condition should actually be that A is greater than B sine A and A is less than B. Okay? And for the first case, it should be A greater than B, not B sine A. Right? So I hope that point is absolutely clear, right? And now let's take the word problem. The application question on sine law, which may lead to ambiguous case, is right here. The question is, a light in a park can illuminate effectively up to a distance of 100 meters. A point on the bike path is 150 meters from the light. The sight line to the light makes an angle of 23 degrees with the bike path. What angle of the bike path to the nearest meter is effectively illuminated by the light? Correct? So let's consider this to be the bike path, for example. And we are saying that the sight line to the light makes an angle of 32 degrees. So let's consider like this. Let's say somewhere here we have light. Correct? So we have light here. And this is 32 degrees. So a point on bike path is 150 meters from the light. So this point, let's call this point as A. It is 150 meters from the light. Is it okay? The sight line to the light makes an angle of 23 degrees, and it makes angle of, 23, not 32, 23 degrees. Correct. Now the question here is, what length of bike path to the nearest meter is effectively illuminated by the light? Now the light path is right there. This is the light path. Now as you can see, as given also here, the light can only illuminate till 100 meters effectively. That means kind of like here, right? So from here, this much portion can be eliminated. So we can say kind of like this. So you can make a circle. Is it okay? So that means we are looking for a portion which is kind of like this. So this is the portion which gets eliminated, where these sides are 100 meters. Does make sense to you? And what we need to figure out is what is this length BC which is getting eliminated, right? Now I hope from this figure it's easier to solve the question, correct? So let's solve it. So basically what we can do here is that since we know this angle is 32 and that side is 100, we can find angle B using sine law, right? So that's what we will do. So we say sine of B over the opposite side of 150 is equal to sine of 23 degrees over 100, or sine B is equals to 150 times sine 23 over 100, correct? Now let's figure it out, how much it is. So we have 150 sine 23 equals to, and we'll divide this by 100. So that gives us 0.586 less than 1, right? That is sine B. So angle B will be sine inverse of all this. Correct? So we'll do sine inverse of this, shift sine inverse of the answer is equal to 35.88. Rounding to one decimal place, we get 35.9 degrees. So angle B is 35.9 degrees. Since the triangle LCB is isosceles, since these two sides are 100, we can find what angle CLB is. So angle CLB should be equal to 180 degrees minus 35.9 minus, this is also equal to 35.9. You see that? Since it's an isosceles triangle, correct? So let's figure this out. So we have 180 minus 35.9 minus 35.9 is equal to, in decimals, 108.2. Correct? And this angle, since it is isosceles triangle, is actually 35.9. Correct? Okay. Now based on this, we can now find CB using sine law once again. So as you can see, first we applied sine law, now we'll again apply sine law to solve this particular triangle. So we can now say that CB over this angle sine, which is sine of 108.2 degrees, is equal to, so this is 100, so we get sine 100 over sine of 35.9, or length CB is equal to 100 times sine of 108.2 divided by sine of 35.9. Okay, let's calculate. So it is 100 times sine of 108.2, and we'll divide this by sine of 35.9. So the answer here is 162, and the units are meters. So the length which is eliminated is actually 162 meters, and that is how you get, right? Now as you can see, opposite 35 degrees it is 100, so this is a much bigger angle, so we do expect a larger value here, right? So our answer is, the path eliminated is, we have to round to one decimal place since it is 162. Let me write 0 here. We are looking for nearest meter, and so this is okay. So we could write this as 162 meters. Perfect. Now let's move on to the last question in this part. Solve triangle ABC where angle A is 40.3 degrees, side A is 35.2 centimeters, and side B is 40.5 centimeters. We should write our answer to 10th place, since all the values are given up to 10th place, correct? So let us figure out whether we do have a special case here with two triangles or not. So let's sketch a triangle first. Let's say that's the triangle where angle A is 40.3 and the side B is 40.5. Now we are looking for the third side to be 35.2, let's say kind of like this, which is 35.2 for us, right? Now in this particular case, whether it is an ambiguous case with two triangles or it is just one triangle or no triangle, let's confirm that part. So how do we confirm? So we'll just check the value of A with respect to B sine A. So what is B sine A? B sine A in this particular case will be 40.5 sine of the angle 40.3 degrees, right? So it is 40.5 times sine of 40.3. That gives you 26.19. Now clearly A is greater than B sine A. And we also know that A is less than B, right? It is less than 40.5, and therefore we have two triangles. Perfect. So that is to say, we are looking for two solutions. The other triangle will be kind of like this. Do you see that? Where these two sides are 35.2. So let's name these triangles. So we have this point as B, this is C, and we'll call this as B dash. So let's solve the bigger triangle first. To find angle B, we can say that sine of B over 40.5 should be equal to sine of 35.5. That's okay, sorry. Sine of 40.3 over 35.2. Okay. To find B, we'll do sine B equals to 40.5 times sine of 40.3 degrees divided by 35.2. So 40.5 times sine of 40.3 equals to, and we'll divide this answer by 35.2, which is 0.744, let's say 2. So angle B is equals to sine inverse of this angle. You could do all this in one step also, right? So we'll say 0.7442. I'll use this value, right? So the shift sine inverse of our answer is equal to 48.08. Rounding to one decimal place gives us 48.1 degrees. So in this particular triangle, we get this angle as 48.1. Now, let's solve the big triangle completely. We'll also find side AB, right? Now, if this is 48.1, now we'll consider triangle ACB. So the angle C, I should write ACB, is equal to 180 degrees minus 40.3 minus 48.1. So it is 180 minus 40.3 minus 48.1. In decimals, it is 91.6 degrees, correct? Now, since this angle is 91.6, so we are actually solving the bigger triangle, which is kind of like this. Let's redraw. So here we have 40.3, this is 48.1, and we just found this as 91.6. The sides are 40.5, 35.2, this is C, this is A, and this is B. Perfect. This is what we're trying to solve. Now to find AB, we say AB over sine of 91.6 is equal to, we can use this 35.2 over sine of 40.3, correct? So AB is equal to, cross multiply, 35.2 times sine 91.6 divided by sine 40.3. So we get 35.2 times sine 91.6 equals to, divided by sine 40.3. So that gives us 54.4 to one decimal place. So we found the side length AB, correct? Now let us solve the smaller triangle, which is kind of like this. So I'm just enlarging it a bit to draw. Okay, so that's the triangle where the sides are A, this is B dash, and this is C for us. So the smaller side, we can find that angle from, so the angle, let's find the angle ACB dash. AC, you could do it, let's see, ACB dash will be equal to how much? So we're looking for this small angle now, correct? Now we know that this is 48 point, this one is 48.1. So how much is this angle? Well, exterior angle is sum of these two, correct? Exterior angle is sum of these two angles, and therefore ACB dash should be 48.1 take away 40.3. So that is 48.1 take away 40.3. So we use exterior angle theorem this time, 7.8 degrees. So this angle here is 7.8 degrees. And therefore the side AB dash should be equal to, so we'll just write sine law first and then figure it out. So AB dash over sine of 7.8 is equal to, we are given 40.5. This side is 40.5. And that angle is sine of 180 minus 180 minus 48.1. Does make sense to you, right? So therefore, AB is equals to 40.5 times sine of 7.8 over sine of, let's do this, 180 minus 48.1 in decimals is 131.9, right? So let's calculate. So we'll do 40.5 times sine of 7.8 and we'll divide this by sine of 131.9, which is 7.384. Rounded to one decimal place gives us 7.4. The units are centimeters. Perfect. So that is how we could actually solve these two triangles. So this side over here is 7.4 centimeters, and earlier we found AB as 54.4 centimeters, correct? The units are centimeters and the angles are in degrees. So I hope with this you got a good review on ambiguous cases. It's a special case which we can solve using sine law application. Feel free to share your comments and views. You can always subscribe to my videos and refer them to your friends. Thanks for watching.